This is part 2 of our video on geometry review, and we are going to go through a couple of questions that involve circles. So up first, I have this diagram. There is a circle, and it has some lines on the inside. We've got a 25 and a 48 degree that are marked, and we want to figure out what x and y are. And this little dot in the center just shows where the center of the circle is. So on my formula sheet, there are 3 different circle theorems that we learned. And actually, 2 of them are the same theorem, just one of them is a special case. So inscribed angles are angles that are drawn from the same 2 points. So in this picture here, an inscribed angle goes from a point on the circle to another point on the circle, and then to a third point on the circle. Another inscribed angle is going to start from the same point as the first one, but it's going to go to a different point on the circle and then end in the same place as where the other one ended. So they need to start and end from the same points, and they need to go to the edge of the circle. Those angles, if they are inscribed, are equal. Okay? The other theorem we learned was the central inscribed angle theorem. So an inscribed angle goes from the edge of a circle to the edge of a circle to the edge of the circle. A central angle goes from the edge of the circle to the center and then to the edge. And to be the central inscribed angle theorem, you need to have both angles being drawn from the same set of points. Okay? So in the inscribed angles, we said that those 2 angles are equal. In the central inscribed angle, the one in the middle, the central one, is double the inscribed one. So either y equals 2 times x or x is half of y. And then the third one, the CIAT, is a special case. This here, the central angle, it's a weird one. Doesn't really look like a central angle, but it is. It goes from the edge of a circle to the center to the edge. That's a straight line, so it's 180 degrees. And then this angle is always double this one, so half of that is 90. So anytime you have a perfectly straight line going through the center, or the diameter, right, a triangle drawn off of that, that angle will always be 90 degrees. And it's just a special case of the central inscribed angle theorem. Okay, so now that we've taken a look at the rules, we're going to look at our diagram. And I'm going to start with angle x. If I trace angle x is this angle there. Is there another angle being drawn from those same 2 starting points? Yes. This angle here is being drawn from those same 2 points, and it is 25 degrees. So x is just going to be 25 degrees because of the inscribed angle theorem, or IAT. No calculation is required, right? It's just going to be 25 degrees. Now, angle y, it might help if I turn my page around, because angle y is this angle here. I'm going to turn my page around. So starting from these 2 points, is there another angle that was drawn from those 2 points? Yes, this angle here, the 48 degrees, was also drawn from those same 2 points. So angle y and angle 48 are going to be the same thing. So also inscribed angle theorem, no work required, and then 48 degrees. Okay, if we take a look at our second example, right, you'll notice this time I have one angle that is being drawn to the edge of the circle. That's an inscribed angle. And then I have one that is being drawn to the center of the circle, which is a central angle. So we are working with this one. We're trying to find y. Do I have another angle that is drawn from these same 2 starting and ending points? Yes. That would be the 11 degrees. Does y equal 11 degrees? No. Right? The theorem we're using is this one, the central and inscribed angle theorem, that says y is double x, or that x is half of y. So I am using the central inscribed angle theorem. And y is going to be double x. So y is going to equal 2 times 11. 2 times 11 is 22. So it is going to be 22 degrees. All right, last one. I have a circle. I have a line going through the center of the circle. That's the diameter. And then I have a triangle being drawn to the edge off of that. So looking at my theorems, this is the special case of CIAT, right? So this angle here should be 90 degrees based on this theorem, right? So that angle X should be 90 degrees. No calculation is needed. And that is the special case of CIAT. You don't have to say that it's the special case. You just have to know, right, that it's just a special case of that rule. All right, and then from here, that's the only thing that I could get off of here, right? None of these other circle theorems apply, but the 40, the 90, and the y are all part of a triangle. So I would use my sum of the angles in a triangle theorem that says that those three angles add to 180 degrees. So I'm going to use SATT, and y plus 40 plus 90 will equal 180 degrees. I'm going to collect up my like terms here. 40 and 90 is 130. And then if I subtract 130 from both sides, I get that y equals 50 degrees. All right, that is it for our geometry review.